Good afternoon, everyone. This is Allie Mastardo, Senior Association Manager of PPRA. Thank you for joining us today for the roadresource.org webinar, Making the Most of Asphalt You've Already Paid For, Asphalt Recycling and Reclaiming. This is the fifth webinar in a series of 6 that are planned for this year. We do have you all on mute for the webinar and will be using the chat function for any questions. Questions will be answered at the end of the webinar. A brief introduction before we begin. Lindsay Matoush is President and CEO, and Grace Sansberry is an Account Executive at Vario Consulting, the marketing firm that has partnered with PPRA to create roadresource.org. Over the course of the year, they will be presenting a series of webinars on roadresource.org. Scott Ostenmacher of Asphalt Material and ARA's Technical Director, Steve Cross, will be assisting in today's webinar. We will now turn the webinar over to Grace and Lindsay.
Good afternoon, everyone, and thank you for joining our webinar on asphalt recycling and reclamation. As Allie mentioned, Grace and I are the facilitators today. We have partnered with the associations as the researchers who explored what agencies were looking for out of a site like this, and we have designed and built the website at roadresource.org. We are not subject matter experts when it comes to asphalt recycling itself. To join us as subject matter experts, we have 2 professionals we have deep respect for who are also trained road resource super users, which means they've both gone through day-long training about how to use all the ins and outs of the website. We have Scott Ostenmacher with Asphalt Materials. He's a PE and currently works with agencies on behalf of Asphalt Materials to help them think more proactively about how they maintain their roadways. He's also a former county highway engineer, and so he brings a deep understanding of what it's like to be sitting in that seat trying to figure out the smartest way to manage your roadway networks. He's been really instrumental to us in helping to make the site as user-friendly as possible. So he'll be sharing with us a couple real-world examples today. And then we're also privileged to have Dr. Steve Cross join us. He's a PhD, PE, and he is currently, in addition to being a professor, in addition to being a well-respected and frequently published researcher, he's also ARA's technical director and is the most knowledgeable person I know about asphalt recycling, so he'll be walking us through some more of technical aspects of this conversation. What we're going to cover today is some of the benefits, the high-level benefits of asphalt recycling and agencies who are making really good use of these treatments, what they're finding and experiencing. We're going to take you to the Treatment Resource Center, which is kind of the really deep section of the site that provides technical insight and resources. We've built a structural calculator that helps you compare not only the cost savings or environmental benefit of different treatments, but also the structural gains that you can achieve with some of these recycling treatments. So we'll be showing you a couple different examples of how to use that tool today, and then we'll share some real-world examples of agencies who were needing to address really particular challenges on their roads and how they were able to use some asphalt recycling treatments that saved them time, money, and many of their existing resources. So before we get into the meat of the presentation, we always like to give a little bit of background on how we got here. You most likely are familiar with these 3 associations, the Asphalt Emulsion Manufacturers Association, the International Slurry Surfacing Association, and the Asphalt Recycling and Reclaiming Association. Those 3 organizations came together to form the Pavement Preservation and Recycling Alliance with 2 goals. How do we help roadway decision makers achieve better roads today, but also make smarter choices across their entire network to achieve stronger networks tomorrow? We did a big research project in 2015 to understand how agencies and roadway planners and decision makers across the country were making choices about their treatments, and what we realized, what they needed out of the industry, what they needed EMA and ISSA and ARA to provide. And really what was birthed out of all of that research and a strategy that followed was this singular goal and singular promise, and that was this. The 3 associations gathered and said, we need to do whatever it takes to empower agencies to be the best possible stewards of their road networks and taxpayer dollars. I remember sitting in some of those early sessions with leaders and saying, what's the goal of anything that we're going to build? This was before we even knew we were building a website. And they said it's not about selling more asphalt recycling treatments. It's not about selling more emulsions. It's about helping every decision maker out there be the very best steward they can of their asphalt, pavement, and of the taxpayer dollars. And we know that our treatments are a really important means to that end. As I mentioned, the research project we did, we talked to well over 100 different agencies and decision makers across the country, across North America. We talked to people in different climates who carry different roles in the decision-making process, from directors of public works to state highway officials to county engineers to inspectors, boots on the ground. Said, what's it going to take? And what we were really interested in was learning about the agencies out there who were really achieving network level gains, and that they weren't getting necessarily more resources to maintain the miles than anyone else around them, but they were using those same resources better and able to actually reverse the trend of deteriorating networks. We have a lot of respect for you guys who are in these shoes, trying to make every dollar go farther than it can, and having in large part what we think is a pretty thankless job. So we said, okay, what is it that these guys are doing to stretch their resources further? And we came back with 4 key conclusions that we learned from what we'll call these best practice agencies. And there are 4 things. Number 1, they had a really robust arsenal of asphalt treatments, and they knew when to use what. They didn't just have 1 or 2 treatments they were comfortable with. They didn't just revert to standard sort of mill and fill or thin overlays. They really had quite a few treatments they could pull from, and they knew which roads were candidates for which treatments and how they could pick more cost-effective or environmentally effective treatments to stretch their budgets further. Number 2, they really thought with a network mindset. It wasn't just, what am I doing with this road? How am I spending the money this year? It was, how am I allocating what I have to improve my overall network? And there's a lot of resources we've built to help you guys with that decision making we'll cover in a second. Number 3, they were really paying attention to what their peers were doing around the country and how they could draw from the success and the innovation that other agencies were having and build on that success. We know that as stewards of your networks, you're not going to try treatments if you're not really comfortable that you can apply them successfully. So what we found was there were agencies out there who were saying, hey, it's not just what I've tried, but what other people in similar regions and climates have tried and had great success with. I can build on that and learn from that. And lastly, they were in touch with the industry at large. They were connected to really smart manufacturers, contractors who do these treatments all day, every day, and just have a tremendous well of expertise. They were connected to the research. And so really what we did was build Road Resource to help more agencies have access to these tools and to make it easier for you to move the needle. This is the 5th webinar in a 6-webinar series this year. On the first 3 were on network level concepts. Those are great listens. You can get on the website and listen to them. I'll show you where a little later to help you think about network spending. We recently did one on asphalt emulsions. Today we're talking about recycling, and please mark your calendars for November 20th. Thinking about getting ahead of the curve, and we'll dive pretty deep into pavement preservation. So what we're going to do is take you to the tool that we built as a result of all this research, is roadresource.org. It's a 500-page website that has a tremendous amount of tools that are all free, that were built for you by the 3 associations who form the PPRA to really help you learn and grow with these concepts and be that best steward possible of your roadway networks. So with that, I'm going to let Grace take over and talk a little further about asphalt recycling.
Thank you. So when we started thinking about asphalt recycling and what we needed to teach on, the first thing that we thought about it, what are the major questions or challenges that most agencies face when using recycling and reclamation treatments? And this is a really interesting question because it's typically many-fold. And the first of those that we know is that the number one biggest thing that agencies face when considering or thinking about recycling or reclamation treatments is some of the misinformation or misunderstanding that's out there. Recycling treatments aren't as straightforward as the conventional when we start learning about them initially. However, the added benefits, the cost really add up and can be very valuable for agencies to keep in their hopper.
One piece I'll add here, when we did that initial research project, we would ask agencies, what are your questions about asphalt recycling? And what do you believe about some of these different asphalt recycling treatments? It was really, and I would just record what people had to share about that. And what was really interesting was finding the deep degree of misinformation that people held that they held it as fact. And they would frequently say things like, well, asphalt recycling treatments cannot give you the same structural gains as new pavement. Or cold recycling is more brittle. Or they would have these deeply held beliefs about emulsions or things, and maybe it's something that had happened in a treatment in their area. I'm not sure where they came from, but we organized all those things that people believed. We're not technical experts to know whether they're true or not, and shared them back with industry leaders who do these treatments day in and day out. And it was shocking, the sheer amount of misinformation and misunderstanding about some of these treatments, and that matters if misbelief is keeping us from trying things that could really protect our existing resources.
The next piece is that people can be hesitant to try new approaches. As Lindsay mentioned, without having the confidence that a new treatment that you're going to apply will succeed, without completely understanding everything you need to know about it, people tend to be more hesitant. And so our goal was to equip agencies with the information that they need up front. What are the things I need to be thinking about before I apply this treatment? How do I know I'm applying it correctly? What are the quality assurance steps that I can take to keep this with the utmost quality? And so that's another thing we work to address on the website, to really equip people with confidence and the right information. And the third is, let's say I'm already on board with recycling treatments. Oftentimes there are hurdles in convincing or explaining to others within my own department, whether that's my engineers, decision makers, the folks who hold the purse strings. How do I explain to them that reusing our existing roads or taking a non-conventional approach, quote unquote, can really go a long way for my network? And so we wanted to equip people with the right tools to describe and explain these innovative new treatments and how they can really benefit the network. Scott or Steve, is there anything that you want to add to this? I know that, Scott, you've had a lot of experience being that agency side. Anything to add?
No, I don't think so. I think you hit the nail on the head there. I think you pretty much covered it very well.
Thanks.
Great. So with that, we're going to jump into the website. And so understanding that these are some of the challenges and questions that agencies face, we wanted to really equip you. And the first place we're going to take you to is the recycling section. This is really important for some of those broad, high-level understandings and ways to see the benefit. So if we're on the homepage of the website at roadresource.org, feel free to follow along. We're going to run over to the recycling tab here on the far right. This is where you'll find all of the information that you need relating to recycling treatments. We're going to head to Why Recycling and Reclamation. This gives the top line information here. It shows you a little bit about what recycling treatments can do for your network. The top line here is that it's lower cost, they have equal engineering advantages, more environmental benefits, and time savings than the conventional methods, often because you're not trucking, because these recycling treatments are placed in situation and reuse your existing materials, there are incredibly fewer trucking traffic. So as far as lower cost goes, they can be less expensive than the traditional mill and fill or remove and replace. because of that reuse of materials. You're not paying for excavation, trucking, and it reduces burden on your surrounding roads. Often when we're trucking in and out for mill and fill, those heavy trucks and traffic can actually increase wear and tear on your surrounding roads, further deteriorating other parts of your network because you have to bring in all that material. Recycling treatments can achieve structural values similar, equal to hot mix asphalt. This is another one of those misconceptions. People didn't believe that you could engineer roads with the same strength. And we'll walk through the calculator a little bit later how we can find not only stronger roads, but stronger and more cost-effective roads, looking at that structural number. So we can enhance performance with better strength, impermeability, and flexibility, recycling the material that we've already used, including eliminating the need for a leveling course and the ability to address reprofiling and road widening. Some nice ways that you can really work with that. And of course, the environmental benefits. Reusing existing materials does a lot for the environment, reducing fuel consumption and greenhouse gases. This is something that can be especially relevant for non-attainment areas. And if you are an agency member who is already currently doing recycling treatments, and for some reason you're not sharing the environmental benefits with your taxpayers, with your decision makers, this is a great way to get credit for the good work that you're doing, because more and more we're finding that this is relevant to decision makers up and down. And then, of course, time savings. Most recycling treatments can be open to traffic immediately after completion. And the in-place work obviously cuts down on time with trucking and hauling. And you can, it makes it a lot easier on your driving public. And one just neat little factoid, many of you may know this, the amount of RAP milled off U.S. roadways each year is an incredible amount, between 80 million and 100 million tons. And in Virginia alone, we like this fact, in Virginia alone, the current RAP stockpile could pave a 12-foot lane, 6 inches deep, all the way from Virginia to Utah. If you think about the roads that you've already paid for, the amount of money you pay for a new road, there's a reason that we call RAP, recycled asphalt, black gold. It's just so valuable to your community. And so if you're on this page and you're working through maybe an explanation of what recycling is, this is a great place to take somebody to explain why you're recycling your roads or why it's important that you start. There are other resources at the bottom here, including a link to our structural calculator, which we'll work through. Which treatment is right for my road tool. We walk through that on several other webinars. Feel free to check that out. And right now we're going to take you through the Treatment Resource Center, where we get all of that good relevant information about our recycling treatments. So you can click through here, or if you're looking in the main navigation, it's up here under the treatment section of the website.
So this, I just want to remind you guys that we are keeping an eye out for questions in the lower left part of your screen there, where you can ask any technical questions you have or questions for clarity on the tools within the website. So we're keeping an eye on that as we go, but I want to take you to a place where many of your technical questions will actually find an answer. So as Grace said, this is the Treatment Resource Center. When we say this website has 500 pages, many of those pages live here. This is something that we agreed needed to be done for the industry, for agencies, to make this easier, because what we realized in listening to them was all these different treatments have different ways of approaching the quality and technical conversation. So here there's 18 treatments that all have the same menu for technical insight. So we'll take you quickly to full depth reclamation and show you an example of what you can find here. On the top right there, you see, if you're here and you want to see a different treatment, you can click on more treatments and navigate to another one, but we'll stay with FDR for now. So if you look on the top left, you'll see we start with a basic about, right? So as you're trying to get familiar with different types of treatments, this is a great place to read a little bit about this treatment. What does it do? We've got some high-level benefits there of some common savings or saving ranges people experience in terms of not only financial but green or environmental savings, the recycling impact, the time savings. So for example, here we see that you can have same-day return to light traffic. What sort of life extension is possible We'll tell you a little bit more how we got that number, and then any sort of structural contribution. You also see a little bit about the issues that we're addressing with this treatment, the attributes of the treatment itself, and some common combinations. One thing that we're finding fascinating across the country is the ways that agencies are combining some of these more cost-effective treatments for tremendous life extension. So that's a little bit about it. Then you can go to process and variations, because most of these treatments have more than one way of doing them. So here you get to see the variations in equipment, and you also get to see the variation in materials. This is a good way to dig a little bit deeper into the different ways that people are using this, and then there's a bit more here on common combinations. There's a little bit about expectations, recognizing that if you use some of these treatments on a road that's deeply distressed versus lightly distressed, you can expect different things. So here we're showing you what you can expect, and I just want to quickly say that in the calculator tools that we're going to show you in the rest of this site, we have selected the average life extension. So we didn't want to overpromise or underpromise. We selected average. We do find, however, that many agencies are getting more life than we've assigned as average. There's some information, and in some cases there's pictures of what do these treatments look like? What can you expect that road to look like? Not just before and after, but in the bottom right there, you'll see 5 years after, what does that road look like? And this helps you really get a sense of what you can expect for the long term. Some information about cost and history and best practices. There's a whole section on pre-construction, from site selection through spec review. In many cases, we're linking to specs that exist or spec guidelines, especially if ERA or ISTA has set something. There's a big section there you can see around construction, from preparation through equipment, traffic control, application. One thing we heard from agencies is they really wanted to know, okay, you guys who do this all the time, what are the tips and tricks in laying this? What are the best practices? What are the little things that kind of might sneak up and bite you? Or what could go wrong? So we've really tried to organize that here, building on the insight of the contractors and manufacturers who have really a lifetime of expertise with these treatments. So if you'll click on application, you scroll down, you'll see it's almost like you've got a step-by-step guide of how FDR gets applied. And then throughout the site, you'll see that in many places we've organized best practices. And back up in the best practices section, if you click on this, you'll see these are just the little tips and tricks and best practices that all these applicators have found. And this is a great place to find some of that excellent industry level insight. We recognize that this is not a substitute for talking to people who do this every day. So there's a link up there to find a contractor or a supplier. Many of the agencies that we found having great success had not just vendor relationships, but partnerships with the contractors and suppliers in their areas who could really help them figure out what do they need to know. This part of the site concludes with a section around quality assurance. What do you need to know about inspection, testing, and troubleshooting? Where we have them, there's pictures. And then these last two I think are pretty important, our second to last two, research and performance and success stories. One thing we heard from agencies is they know that there's research out there, but they don't always know what the research says. They don't know which reports to read. They don't always know how to find the key conclusions. So in most sections of the site, we have organized what we think is sort of the best of or the most pertinent, relevant research for you. So there's a 2-sentence summary, then a link to a bigger summary and the full report if you want to dig deeper. And the goal is to make it easy for you to just skim one section and find out, okay, what's the research really saying? And then there's a section around success stories. It goes back to what we said in the beginning. People are really looking to say who else is having success and how. And so where people are having success using this treatment or where it solved a very particular problem for them, we've got these success stories. If you click on them, you can read what did this agency in this exact scenario experience, the problem, solution, and then if there's a quote from some of the team members who did that work, we've got that highlighted here along with some photos of the job. You can download that and share that with others in the department if needed.
So this Treatment Resource Center is a great asset to you, knowing that there is information on 18 different treatments, including all of the recycling and reclamation treatments covered under ERA. It's a great place to start if you have specific questions about treatments. In the vein of equipping you to have confidence and success. But what if I'm comparing treatments? So what if I'm considering cold in place versus a conventional approach or comparing treatments somehow? One of the key aspects for recycling treatments is how much strength or structure that treatment's going to give me on my road. Not every road has the same structural demands, and it's an important thing to keep in mind when we're comparing things, in addition to the cost of the road, the environmental impact, all those other factors that we've walked through. So when we're looking at the structural calculator, we're going to start over under the recycling side. There's two tabs to each of the calculators. There's an About, which explains how the calculator works and what we're considering, and there's the actual calculator piece itself. Real quick, I'm going to go through the About. Dr. Cross is going to explain a little bit about how and where this came from in just a moment, but when we're comparing or considering comparisons of each treatment, we've got a little bit of a walkthrough for you here. If I'm comparing CIR versus mill and fill on a specific road, this is just an example. HIR versus mill and fill, FDR versus reconstruction. Again, these are examples about specific roads with specific structural numbers, cross-section depth, etc. So we're looking at a couple different factors. Not only the cost for each treatment, the conventional mill and fill, or on the right, what if I tried cold in place? What does that material design look like? But also the structural number itself. How can we achieve the same or better strength for a lower cost? And a little bit about the structural number, I'm going to throw over to Dr. Cross in just a second. Are you on with us, Steve?
I'm here.
All right. Tell us a little bit about that.
All right, what I thought I'd do is, for those of you that are not familiar with thickness design, I thought I'd give you a real brief introduction to the AASHTO design guide procedure. And the whole point of that really is just to give you an idea of where these structural layer coefficients come from. So all of this came from what was in the AASHTO road test, and they were on the future route of I-80 by Ottawa, Illinois. And the road test consisted of 6 loops. There were 4 that were trafficked and 2 that were set up for environmental conditions. And they had different asphalt and concrete sections on each one. So if we can go to the next slide. One of the things to remember, and was kind of unique about this, is that materials were not a variable in the asphalt, in the AASHTO road test. So there was one asphalt mix, there was one crushed stone base, it was a limestone, and then there was a sandy gravel subbase material. And they've had all these different test sections of all these different combinations. So the asphalt surface varied from 2 to 6 inches in thickness, the crushed stone base 0 to 9 inches, and the sandy gravel subbase from 0 to 16 inches. One of the conclusions they found out pretty early is the sandy gravel subbase was a rounded material, and they didn't particularly perform too well. So you'll see in lots of part of the country, sandy gravel subbases are just not used anymore. So next slide. Really what they came up with, they drove traffic around around all those different loops for a couple of years. I think they had about 2.3 million total easels on it. And what they came up with was, again, there was just one soil, one subgrade out there. So with the more traffic that you had, the higher structural number you needed to give you the same desired level of service. So again, as traffic goes up, you need a thicker pavement section. And then also then if the soil quality of the soil goes down, you're going to need a thicker pavement section as well. So let's go to the next slide. The other thing they came up with all these different combinations, they came up with a structural number. So the idea was that any combination of materials, as long as they added up to the right structural number, would perform the same. So they developed the structural layer coefficient concept. And for our asphalt, they assigned 0.44. For crushed stone base, it was 0.14, and sandy gravel, it was 0.11. So to get the structural number, you just take the layer thickness times the A coefficient, and then sum those up and give you the structural number. So again, theoretically then, any combination, as long as you went from stiffer to softer as you went down, would perform the same if the structural number was the same, although I'm not sure everybody agrees with that. Let's go to the next slide. So this is the thickness design equation from the 1993 design guide, the AASHTO design guide. It's a fairly complex equation, but on the left-hand side, the log W18, that's your design traffic in 18 kip single axle loads. There's a reliability factor, that's the ZR and S0. We're trying to solve for SN. You see that in there a couple of places. It's kind of based on what initial smoothness or serviceability we want and what serviceability we want when we decide that the pavement has reached the end of its life. In the bottom, the log MR, that's the subgrade strength, or the seasonally adjusted resilient modulus of the subgrade. So if I want to design a new pavement, I determine my traffic, I determine the seasonally adjusted resilient modulus of my subgrade, my delta PSI. I plug all these in and I solve for the structural number. And then it's just a matter of manipulating my layer coefficients, my thicknesses of the material until I get the required structural number. So for new construction, it's fairly straightforward. Let's go to the next slide. Overlay design gets a little more complex, and there's several different ways to do this, and I'm going to show you one of them, and just realize that overlays were not a part of the AASHTO road test. But what a lot of people do with an overlay design, if they want to figure out how much structure or my structural number I need for my overlay, I basically design a new pavement over the existing subgrade using that equation we saw on the previous slide, and that's my SN future. My existing pavement has some structural value, so that's what we call SN effective. And so you subtract those two, you've got to make up that difference with the structural number of the overlay. And then the thickness of the overlay is just the structural number of the overlay divided by 0.44, the A coefficient. So again, the easiest way, this is not too hard to do. It's easy to get the resilient modulus of the existing subgrade, and you just plug your numbers in to the existing, to the equation. So let's go to the next slide. So where it gets a little bit more complicated is how do I get the effective structural number of the pavement? Realize it's not as strong as it was before, so those A coefficients have gone down, so I don't have as much structural number. So there's a couple of different ways we can do it. There's a direct method. We can use the FWD, and we can calculate the SN effective using a couple of equations from the FWD. So that's kind of a direct approach. Or we can use a back calculation that I'll show you in a minute. We can get the modulus of each layer and get it that way. For lower volume roads, and sometimes we can't afford an FWD, you can come out with the dynamic cone penetrometer. That'll give you an idea of the strength of the subgrade and maybe the aggregate base, but you really can't get much information on the asphalt layers. You can cut cores and combine them with the DCP and come in with SN effective. And then there are very simple condition surveys where you just go out and look at the pavement and decide this is what it is. So let's go to the next slide. The most common is FWD with agencies, and again with the FWD we drop a heavy weight on the pavement, we get a deflection basin. If I know the thickness of the layer and Poisson's ratio of the materials, I can back calculate or can estimate modulus values of the layers until my deflection basin matches my calculated method. There is an equation with the FWD where you can calculate SN effective of the pavement. The only problem with that, it gives you the SN effective of the entire pavement structure above the subgrade. You do not know the A coefficients of the individual layers. Or I can use back calculation, and I can determine the modulus of the aggregate base and the asphalt layers on top of it. So let's go to the next slide. And then if I know the modulus of each of my layers, there are equations in the design guides and charts as well where you can come in with your modulus. You need to correct it to a standard temperature, come up and get an estimate of the existing A coefficient of the layer. So lots of different methods to do that. Now let's go to the next slide. So if we're looking at the structural calculator, we do need to know the A coefficient of the existing layers, especially if you're going to do a mill and overlay or a remove and replace. You're taking away some of the structure of the existing pavement. You have to adjust SN effective accordingly. So when we're looking at the calculator, you'll see a couple of examples. It gives you SN future, and again, SN future is equal to the structural number from the overlay plus the structural number of the effective pavement. And if you're going to somebody and just talking to them about you've proposed option A, I want to give you an option B, you probably won't know what A coefficients were used to get SN effective. And so we've provided some default A coefficients. But one thing to keep in mind, the assignment of A coefficients are agency decisions. They do vary across the country a little bit, and you can always ask them what they use. It may be different than what's in the calculator. So let's go to the next slide. So here are the A coefficients. I've got two things here. We've got the different treatments. I've got what I've seen as typical ranges. You may have seen something different. And then on the far right is the default value that's in the calculator. And again, those default values in the calculators are all user changeable if you want to change them to something else. But we're using 0.44 for new asphalt, new aggregate base 0.14. FDR, the three different types, we're all using 0.22. That's an average of different types. They do vary, and we typically see mechanical being a bit lower than 0.22 and bituminous being higher than 0.22. For CIR and CCPR, we're using 0.34, HIR 0.43, base stabilization 0.23, soil stabilization 0.12. Old asphalt, this was one that's a little difficult, but I've typically seen people use numbers less than 0.3. You may have seen something else, and our default is a 0.2. And old aggregate base, we're using 0.1. So, like I said, you may have seen something different. That's the values that are in there, and they have been developed using procedures kind of similar to what I talked about. So let's go to the last slide. So the structural calculator is going to compare the structural number and the cost. So you can set up a design where you design for equal cost, and you'll probably get higher structural number using recycling, or for equal structural number, and you'll probably get a lower cost for the in-place recycling. A couple things to keep in mind, though. The existing pavement has a reduced structural value from when it was new. And if you're trying to select A coefficients, the more severe the distress, and more than likely the lower the structural layer coefficient would be. And then the last thing, if you're doing complete reconstruction where you remove and replace, there is a cost associated with removing the materials, and you'd have to enter that cost yourself. We don't have national averages for that one. So with that, I know that was a quick overview, and I'll turn it back over to Lindsay and Grace.
Thanks, Steve. That's to give you guys a bit of a background about where the numbers came from in the structural calculator and things you should be considering when you're comparing structural value and cost using this calculator. One thing I want to make sure to highlight, as Dr. Cross said in this slide, we've included default values for you to use if you don't know the A coefficient of a particular treatment. But it's important to know that you can alter those and change those in the calculator itself. So let's see, if you go ahead and log in the top left of in the top right of your on your browser here is the login button. If you haven't already created an account, go ahead and do that. That'll give you the ability to toggle things like cost input, the amount of life expectancy or life extension you expect to see from your treatments, and also the costs associated with different treatments based on their depth. So that's just one place where you can go ahead and do that in the top right. If you're not already a registered user, that's a place to do it. All of your data stays with you. Nobody monitors that. We take a lot of care to make sure that that stays completely with you and doesn't get seen by anybody.
And what you'll see, what that does when you change it, is it changes all the calculator tools on the site. So we're about to take you to the structural calculator, which is preloaded with certain values that we think are conservative or average, and this will automatically repopulate with your values if you've taken the time to fill out a profile. It makes every tool on the site more useful to you.
So back on the About page of the structural calculator, just to review a little bit about what we're comparing, we have an existing road, which in this case, if we're comparing CIR and mill and fill, we've got about on this fictional road, we've got 2 inches of an HMA wearing course, 4 inches of a base course, and 8 inches of a sub-base or a granular base. And so when we include the structural coefficients, when we include the A coefficients for each of those multiplied by their depth in inches, we get the structural number, which we then sum total for the approximate structural number for this existing road. So we've got a deteriorated road with a low structural number, and we have a couple options when we're comparing these two things. Number one, mill and fill, you see on the left side. Here's what it would look like if we did 3 inches of mill and fill. We left some of that remaining asphalt, and we left that granular base. We'd come back with an overall structural number of 2.88 in this instance, demonstrating this particular fix. And using those North American averages, our cost per square yard would be $16.64. Whereas if we compare to the cold in place method with a little bit of thin lift on top, you can see 3 inches of cold in place where we leave that remaining asphalt in the existing granular base. We cover it with an inch of thin lift. We can get to a structural number of 3.09 with a cost per square yard of only $13.67. And then down below for each of these comparisons, you can see some of the other added benefits in addition to the cost. So essentially, we've got an existing road. How do we solve it? We've got those two different options. And you can click through and read the examples. But in this case, we've got Scott Ossenmacher on the line who's going to walk us through a real-life example that he used. So Scott, tell us a little bit about Stony Creek.
Yeah, thanks a lot, Grace, and thank you, Dr. Cross, for giving that high-level explanation of this stuff isn't just pulled out of thin air. There's a lot of logic behind where these different treatments get their coefficients from. So taking that information and putting it into a real-life example here, where we had a county agency that had 12 miles of primary road, so it's a pretty significant corridor. The existing situation was they have 7 to 8 inches of bituminous surface on a decent, good base subgrade. In this situation, though, it was an all-season, all-weather route. And in Michigan, that means that it's susceptible to trucks year-round. So it can and will see frost heaving in a frost-heaving environment. So there's a added value to that additional structure when you're looking at a road that's going to see this kind of truck traffic. So the county did recognize the value of investing in added structure, especially in the situation for a truck route. And then, of course, depending upon how the dollars work out and within their budget, they wanted to use mill and fill as a last resort. So what we did is we sat down with them and said, we want to compare a couple different options for them. Yes, we can compare it to the mill and fill, but in this case, we're looking at, okay, they're willing to look at a recycle option. Let's look at a couple different options for them and see what's going to be best for their situation with this truck route. So we looked at a 4-inch CIR on the situation compared to an 8-inch FDR, and then we both would be capped with a single lift of HMA. So we started off by putting together a spreadsheet, basically. This is pre-PPRA tools, and this is kind of the ugly spreadsheet that was put together, but it was a successful one where they had a situation where this quarter they would potentially be funded by multiple agencies. So we broke it down by township and showed the relationship between looking at an FDR option compared to CIR option. And when all the smoke cleared, looked at it as, hey, you could see for a little bit of extra cost going with the FDR option, you could see a significant increase in your structural value, and ended up being a successful show and tell, and they ended up moving forward with the project with going with an FDR option. However, had I had this tool like we do today, would have done something like this. And Grace, I think what we'll do is, do you have just the populated examples there?
Let me jump over. I was going to input them for you, unless you want to go through the slides.
I was just thinking, if you want to jump through them, that's fine. I was just trying to conserve time here, whichever way you want to go. So we're looking at comparing the conventional approach. First, we're going to look at the conventional approach of 2 levels of mill and fill of 2 inches, because that's the situation we got there. Basically, it would be the 4 inches we're going to be taking off, and then you've got your 3 inches of existing asphalt remaining yet, on top of your 4 inches of existing granular base.
So I'll just stop you right here real quick, Scott, if that's okay. I want to just let everybody know how this calculator works. So we're comparing 2 different approaches and comparing the structural number and the cost. So I'm making sure to input the cost associated in Scott's area, actually for Stony Creek, as we're going through. We're going to think of each of these lines as a different section of asphalt or material, depending on what we're talking about. So we're going to compare the mill and fill approach with the recycling approach here on the right in just a second, which means we also need to include not only the new mill and fill that we're putting on top, the 2 inches of hot mix, but also the remaining asphalt and the existing base down below that's sort of left over underneath, if that makes sense. I'm going to go ahead and put that in. Is that 4 inches? There we go.
Thanks for that, Grace.
Yeah,
and
thanks.
then our optimized option in this particular case, we're looking at a CIR. So we're going to put that single lift 2 inches of HMA on top, as we mentioned before, because we have to put something over top of that recycle layer. We've got our 4-inch cold in place recycling layer, and then we've got our remaining asphalt, which in this case we got 3 inches of remaining asphalt, and then of course we've still got our remaining granular base of 4 inches.
So I'm going to go ahead and update these costs according to Scott's region.
Yeah, I was going to mention that these here were the cost that she's putting in were actually after the fact the actual cost of the project. So we're looking at some real numbers here after the project was done, and then it was 161,000 squares. If you want to throw that in there. So here we can see the value of the, let's see here, make sure, yep. So here we can see the value of going with the recycle option, going with the cold in place recycling. But they already kind of knew that, so we wanted to take the same situation, and so kind of burn into your brain there, we got 3.24, and we got 2.6 million to go with the cold in place option. But they wanted to look at even a better option structurally to go with the full depth reclamation. So let's change those around, Grace. Let's keep that top 2 inches. Let's just change that second one to an 8-inch full depth FDR. And then our remaining asphalt is actually, we're going to put 4 inches in there, but we're going to have to monkey with the number a little bit. This is something that is going to be improved with the updates coming up within the calculator tool. That this is going to be more customizable to be able to put that to whatever depth of treatment that you so choose. So instead of it being a predetermined depth, we can fine-tune that a little bit more. So we're going to put 4 inches of the existing granular base, and then we're just going to manipulate the coefficient to be 0.075. There's no existing asphalt. I'm sorry.
Oh.
We dug all the way through that asphalt. The FDR took care of all that.
Hey, Scott, we're getting a quick question about why mill and fill is added in twice for the conventional approach.
They were looking to do we were trying to compare similar structural, the amount of deterioration out there, they needed to get down more than just the top layer.
And so basically you needed 4 inches. So you had to do mill and fill 2 inches twice.
That's the way the tool. I think the next version of this is going to allow us to do some additional things here. We can do a 4-inch mill and fill and maybe have some different costs associated with that. But in the way the tool's set up right now, that's the way we have to do it to actually mill out 4 inches.
Okay, and we're getting another question. Does the existing asphalt at 0.2 have to be subtracted in the CIR option?
Have to be subtracted. Well,
the existing asphalt at 0.2 have to be subtracted.
It's not really it's not subtracted. It's more that it's not being accounted for. It's not being it's gone now. It's embedded into the value of the FDR.
So it's not basically it's not sort of accidentally contributing to your overall structural number.
Right, because we're eating through it and basically hitting the reset button.
Okay. All right.
So there's no value there with the FDR. It's being recycled, but it still remains with the conventional approach. So you still get some value for that, even though it's aged and it's lost some of its structural value.
Great.
The other thing is in my calculators, I'm using a coefficient on the high end because we're seeing, at least in Michigan, great results with the FDR. We're using a coefficient of 0.3 is what I'm using for a coefficient for FDR. So if you put that 0.3 in there, the numbers will kind of jive with. But I also, on the CIR, I actually use a little bit lower number, so these kind of work out. But at any rate, we come up with a 3.58 for a structural number compared to what we had before, the 3.16. So the county, seeing that for about $10,000 more per mile on this 12-mile corridor, for about $10,000 more per mile, they were able to see about a 13 to 15% increase in structural number, and it was a no-brainer for them. So had I had this tool at the time, it would have been an easier and more appealing to the eye structural evaluation to be able to use this road resource tool. So it's kind of the after the fact, but you can see how this tool can really help you in resolving a problem or trying to get to an end of finding a certain structural value that you're looking for.
Great. Thank you, Scott. And I'll just hit lightly, too. I know that we're running low on time, but Dundee High School was another project of yours that you're working through where you used this tool and several other tools of the website, the FDR resource pages that Lindsay walked us through earlier. You showed these guys a success story, shared the structural benefits and the sustainability benefits, and really were able to help them out kind of as a full picture.
Yeah, it's a really neat story. It's a very recent story, too, where a consultant came to me and said, hey, he was involved with the school board. He said, hey, they're looking at doing a complete removal and replacement of our parking lots out here, spending a lot of money. Can you help me out and put together something that I can take to a board, present to them, and see if they would consider a recycle option? So what I did is I put together, we're not going to go over all the details, but put together a structural benefit analysis similar to the Stony Creek situation, along with sustainability calculator, which showed the environmental benefits, which is very valuable to those that are making those tough decisions, that can also show, hey, including on top of a cost savings and structural savings or structural added value, we're also going to be saving on the environment too, which is very beneficial for those types of folks in those positions. And we had a very short amount of time to put this together. So using these tools, I was able to quickly throw this together and get that out to them, and also couple that with a link to the information on full depth reclamation in case they want to learn more about the process within the Treatment Resource Center. And then also, which I think this was kind of the icing on the cake, is within that Treatment Resource Center, Grace, if you would jump over there real quick, because you had brought it up earlier, under the success stories within the FDR Treatment Center information, there was a story in there about the fire station, which had a parking lot, and it kind of saved the parking lot situation. So it was very timely. It's perfect comparison, showed the environmental benefits and the cost benefits. But I wanted to mention this quote here that they had put within there: the full depth reclamation process can not only be used on highway projects, but can be used in commercial industrial projects that will save the end user time and money and provide a higher quality finished product. And I thought that was very powerful for this board to consider. And all these things parlayed together ended up them moving forward with going with the recycle option, which is a really cool story in a very short amount of time.
Great. Yeah, thanks for walking us through that, Scott. Before we do questions, I want to just show one last thing. Since we're on the recycling webinar today, we run through things pretty quickly. You know that this is the 5th in a series of 6 webinars. If you're interested to watch, if anyone's interested to watch any of those recordings, underneath the Resources tab of the website, you can click Webinar Series, and you'll see we've got all these videos plugged in. You can go ahead and watch. Each of those are an hour long, so take a nice lunch break and enjoy one of those. Thanks again, Scott, for walking through your stories and sharing with us how we can really put these tools to use.
Absolutely.
So we have a few questions coming in. Before we take them, I just want to point you to a couple more resources. Everything on the site is designed to help you save money, spend smarter, make the right choices for your roads. These are the webinars that you can download right now that will help you with your network thinking. Grace just showed you where to do that. You can also ask an expert here at under the resources section of the site. There's a lot of cool stuff here for you where we'll send those questions to EMA, ERA, and ISSA members who can best answer them. We want to make sure that if we don't get to all the questions today that we don't leave you with unanswered questions. We want you to know if you're not already on it, we're sending out e-newsletters just once a month that organize a lot of really great information, try to curate some really cool things you might be interested in, and you can kind of pick and choose what you want to know more about. So if you're not signed up for that, please make sure you do. And then lastly, follow PPRA on social media. We're on Twitter, Facebook, and LinkedIn, and we're constantly using those tools to feature little bite-sized sections of the site or new information or updates to keep you posted on what we're building. So I'm going to pop over to the questions. So Dr. Cross, if you want to make sure that you and Scott are unmuted, most of this stuff is going to be questions for you guys. Let me hop over there real quick. All right. This is a really technical question, Dr. Krause. I imagine this is to you. Are there any treatments or specific equipment out there that can grind up petromat/pavement reinforcement fabric such that recycling facilities will accept in lieu of hauling to a costly disposal facility? Only aware of cold-in-place recycling process that can handle petromat and an asphalt section. Any other processes or specialized equipment out there? Do you have an answer to that?
Okay, I'm not aware of any specialized equipment that will do that, and you're right. A milling machine, because if it cuts in a down cutting mode, can generally shred any type of paving fabric that's there. The problem is with FDR, it works in an upcutting mode, and that's kind of iffy as whether it can do it or not. But I'm not aware of any specialized equipment, no.
Okay, thank you. Next question, probably again to you. If you were to widen a roadway with, say, 9 inches of 24-foot HMA pavement to 36 to 48 feet, would it be a better plan to use FDR than stabilize after shifting material to have a consistent thickness, or specify CIR and CCPR?
Let me try to answer it this way because I'm not sure I'm gathering your thicknesses. If I want to widen an existing road with either FDR or CIR, well, with FDR, if the material's a little suspect on the shoulder, we want to move it out and put some acceptable material in there, because a reclaimer is not going to move the material back and forth like a milling machine will in CIR. So whatever you mill up, you'll put right back down. And we've seen some issues with that. What we will sometimes see with CIR, if I want to widen the road a little bit, I will mill deeper and place thinner and just spread the material out farther. But the key is I want a consistent material all the way through there. So whichever method gives you that, that's what we want to go.
Okay. Is there a different structural coefficient used for emulsion versus foamed asphalt?
No.
No.
Thank you. Is there a resource, this question was asked, Steve, when you were covering all of the different structural numbers that folks assign. Is there a resource on where is there a database available for these parameters? structural number, a coefficient, costs, et cetera, that we can access?
No, I haven't seen them in a database. You find them spread out through all kinds of different publications and stuff. But again, if you're working with a state on a federal aid, project or a state project, it's an agency decision as to what a coefficient you would use.
Okay.
We have we have ranges that we've seen on our webpage for our materials, though.
On Road Resource, on
Yes.
the Tech Treatment Resource Center. So Eugene, who asked that question, where we were at the Treatment Resource Center, that's a good place to at least start. We're also being asked, is there a resource on where typical treatments are utilized, i.e. where they are typically considered as options to be performed around the country?
I'm assuming they're asking what treatment do I use for what distress that I have on my road?
I think they're asking more like different regions, right? So if you're in a freeze-thaw climate versus a hot, dry climate, that's my guess about the...
Okay, well, from that standpoint, no, that really doesn't affect our treatments. We see people using CIR and FDR all over the country, from, the Adirondacks in New York with high wet snow to the desert Southwest. So we really haven't seen much of an issue with that.
And Stephen, I see you saying yes, that's the question. And we see quite a bit of those types of questions and answers flow through us, even not as technical experts. And I can tell you, connecting with the manufacturers and the contractors in your region, they will always have really good thoughts about how that particular treatment might be contextualized to that region or the particular parameters that you're looking at for your roads.
Very good answer.
Thank you. Another question for you, Steve. Have you evaluated some of the deeper HIR processes, such as dust draw from Kansas recycled 2 to 3 inches?
Yes, I mean the process works well. The deeper you go, the more distress you can correct or mitigate. So, as far as seeing any actual published performance issues, I believe the Kansas DOT has a couple of reports on that process.
Thank you. Can pavement M-E be used in the design of recycling projects?
Yes, and there is an NCHRP project. The number is escaping me right now. Scott, if you remember it, chime in. But it was done by University of Maryland, and they came up with typical or default dynamic modulus values for bituminous CIR and FDR. And it'll work a whole lot better if your procedure is locally calibrated. But Indiana does this.
Scott, a couple questions about your calculator. Why is the existing granular base strength coefficient reduced to 0.075?
Oh, okay, so that's something we will not have to worry about in the future. Basically, we were manipulating the coefficient to equate it to a different thickness of that layer, because the predetermined layers depths that were given when the pull down didn't match up with what the actual layer depth was. So I manipulated the coefficient to make it equal. So I could actually say that I'm using real life numbers in this. So we've got a real structural coefficient and then a real cost associated with that particular project. In the future, that will not be necessary. You'll be able to actually input the depth of your treatment so that you could put in a depth of 1.5 or 1.2, I suppose, if you wanted to, and it would calculate that out. So that will go away. That was just a manipulation thing for discussion purposes.
Got it.
Thanks, Scott. Yeah, and I'll just highlight that. That's an example of where we heard from users that, hey, we think we can make this tool better and easier and service more agencies by changing a little bit of how it works and having the ability to change the number and the coefficient to make those calculations. So we're getting that updated. It's on the list for 2020, and you can look forward to a little bit easier user interface on this calculator.
How is there 8 inches of FDR? That's a question for.
I'm sorry. How is
There's
there?
a question. Yeah, how is there? I don't know if that's saying they don't think that it's possible to do FDR on up to 8 inches.
With bituminous, we generally don't go much deeper than 8 inches in one lift, but if we're doing cementitious, 12 inches is typical. I've seen them go 17 inches in one pass.
Oh.
Not that I'd recommend it, but you can. A reclaimer can chew up like 17, 18 inches in one pass.
Okay.
And if the question is about the calculator function itself, the depth is associated with each of these treatments. So we just selected FDR 8 inches if the question was about the calculator.
And Scott, I think he's just clarifying. He wants to know, was there 8 inches? He says it appeared from the condition that there was not 8 inches available.
Right. So in some, that was an average number over the 12 miles. It varied from like 6 and some odd inches all the way up to a little, just over 9 inches in some areas. So the goal was to get through the vast majority of the asphalt layer so that we're getting into the stone a little bit. So we were completely affecting. You can't fix what you don't touch. We're completely touching through the whole asphalt layer.
Got it. Thank you. Just a couple more questions. How often is the treatment toolbox updated with advances in the industry?
So that is a great question, Jim. The treatment toolbox is an ever-updating piece of the website, and the associations at EMA, ERA, and ISSA all make collective decisions as new research comes out, new stories comes out. We have a committee on each of those associations to review updates in the industry and make those changes onto the website live as quickly and as possible to keep everyone up to date with the relevant innovations and changes as often as possible.
And just so you know, before anything gets posted on the Treatment Resource Center, it runs through technical review from, if it's a preservation treatment, it runs through ISSA. If it's a recycling treatment, it runs through ERA technical committees. And then there's an additional layer of technical review from EMA if that treatment contains emulsions. So you're getting some really good eyes on that stuff before it makes the website. And there are several other just overall website, not Treatment Resource Center updates, but big website updates coming, some new functionality, some cool features, a roadmap that can walk you through it where you can make sure you're kind of checking out everything that it offers. Will be coming in the next few months. I just have one more question, and that is, I believe this is for you, Dr. Cross. Can you discuss climatic effects, i.e. freeze-thaw cycles, thermal cracking on thin as in less than 4 inches, HMA overlays on FDR, specifically cement-treated FDR in cold climates?
You're talking to a guy that's never lived above the Mason-Dixon line. That is somewhat of an issue with using cement with FDR because of the low strength in freeze-thaw climates, and so. But some people have made it work. Unfortunately, I really don't feel qualified to answer that. I just don't have that much experience with it. If you will shoot me an email with that question at steve.cross@okstate.edu. I will shoot that off to some of my friends from up north and see if we can't get a good answer for you.
Thank you so much for that, Dr. Cross. And also, you can ask an expert through the website if you somehow forget that, and that will find its way to Dr. Cross and to his colleagues up north who can make sure to get your questions answered. That is all we have here today. Thanks for the great questions, everyone. Dr. Cross and Scott, thank you for your insight, your expertise, your practical real-world experience. Allie, thanks for organizing the webinar, and we will look forward to seeing you guys on November 20th to talk about pavement preservation. Have a great day, and happy Halloween.
Thank you, everybody.
Thanks so much.